Hello?
Hey, can you hear me?
Yep, seems to be working out.
Hey, how's it going?
Pretty good. How about yourself?
I am doing well, thank you. So, yeah, in terms of, by way of introduction, I'm a software engineer at Microsoft. The team I'm on, what we're doing is that we're building a container for SQL Server to run inside of. That way SQL Server can be ported to non-Windows platforms without changing the source code too much.
Right.
Yeah, so that's a little bit about myself. What's your background?
I guess keeping it anonymous, I'm a, senior at undergraduate studying CS. I've done a couple of previous internships, and mainly I'm just doing practice for new grad hiring.
I see. Okay. So what I have on the agenda for today is basically to treat this like a mock phone screen for Microsoft. So I'll ask you questions of the same difficulty, hold you to the same standards, and at the end of it, give you feedback. Does that sound reasonable?
Sure.
All right, so what we're going to do first, if you could go ahead and pick your language, let's get started.
Sure. We're using
in the meantime.
Python.
Sure, sounds great. So what we're going to be doing first is basically a list manipulation problem. So the idea is that you're given a list of integers L and a number K, right? They ask us to write a function to partition L into regions strictly less than K, equal to K, and strictly greater than K.
Okay, sure. So I guess, Ray said that it's a list of ints. I'm guessing the actual function prototype, I'm given K as the head along with K. Okay, yeah. So I'm guessing this is the prototype is, say, I have some function and head and K. Sure. So what I imagine I could do for this problem is basically starting off from the head. I could try and make 3 separate lists, right? Where the first list is going to be elements less than K, the second list is going to be elements equal to K, and the third is going to be, greater than K, right? I should be able to.
So first of all, let me stop you there. So you're given a list as in like not a linked list. So when you say head, do you mean like a linked list head, or are you just referring to your list as head?
Got it. Okay. So I assumed when you said list of ints, you meant a linked list. So you mean an array of
An
integers.
array of integers, yes.
Got it. Okay. So that definitely changes what I was going to say. Given that it's an array of integers, then it's definitely a bit simpler in that instead of me having to, keep track of these separate references, all I should have to do is go through multiple passes in order to swap values into the correct location. So let's start off with thinking of a worst, solution, right? Like the worst solution is that I could pretty much use a separate array of, length n, where n is the length of the input list. And I would want to just add values to the left whenever, the values are less than k, right? And then I'd add values into the right using pointers whenever it's greater than k, and then the remaining values I can fill in, right, with values that are equal to k. That ends up being a linear time, linear space complexity solution. And I don't think it's really necessary. Yeah, I don't think it's really necessary for me to use the extra array, because it seems like I can just, swap values whenever I want, right? So if I were to make a first pass through and just use that same reasoning that whenever I find a value that's lower than k, I can swap with, say, a pointer I have to the beginning of the array. And then when I have a value that's greater than k, I can just swap with values that are to the end of the array, right? So I'm only using these 2 pointers, and I should end up having that all of the values that are remaining in the middle are equal to k, right? So as an example, if I had 3, 4, 4, 3, 4, 5, 5, or 5, 6, 5, my starting pointers would be here and at the very end, right? So when I see the 3 and the 4, and let's say my k target is 5, all I should have to do is I say, oh, okay, this value is, less than k, then it stays where it is. but my pointer for swapping is still in the same location, right? But the traversal pointer that I'm at is now at index 1. And I see this is also less, so it stays at the same index. I have the 5. I think that can still stay at the same index. It's only once I see the 6 that I see, oh, this 6 is actually less than, or greater than my partition value, right? So now I'm going to swap with the right pointer so that now I'll have 5 and 6. My right pointer is moved here, but my right pointer and my left and my traverse pointer are equal, so I know that I'm done at this point.
Okay.
So that
I think
approach
that
ends up.
That's the idea.
Okay, cool. So is it okay if I code this out?
Yeah. So I think there's a small issue that I think you would run into, but once we write the code, I think the issue will become apparent.
Right.
I'll let you sort of deal with it then, as opposed to making sure that the algorithm is perfect now before writing a single line of code.
Right. Sure. Yeah. I think like one of the things is maybe it's easier to not have a bug if you do 2 passes. But we'll see. So let's say I actually go with that and do the 2 passes, right? It's instead of the single swap. Any potential bug I have coming up should be removed. But you do have like the 2 passes. Is it okay if I go for coding with that instead?
With 2 passes? Why would you need 2 passes though?
For 1 pass to find values that are less and a separate pass to find values that are greater.
I think you can do it in a single pass, right?
Okay, in that case, we'll code with what we said and see what bug comes out. So we have our left and right set to 0 and then len of r minus 1. Just do a check to make sure that r is not none or that the length is not equal to 0. If it is, then kind of just return an empty array. Or really, we just return r, right? Well, I guess this entire thing is in place, so really just return. Cool. So now we have our traverse pointer. So say traverse is equal to 0, and while traverse is less than right, what we're going to say is val is equal to array at traverse if val is less than k. Then we said we were going to swap, right? So we want to do that array of left and array of traverse are pretty much swapped. And we move left up by 1. Otherwise, if the value is greater than k, we're going to swap the right value. Let's just copy some of this. Change this to right. And we end up saying that right minus equals 1. So let's see. I think this ends up being the translation of the idea we had from before. But let's try this.
One thing, right? Like, when do you advance your traverse pointer?
Oh, right. So this was, I don't always end up updating traverse. In the idea, I said that it would pretty much end up being this, and that I always update traverse,
right.
But not entirely true, right? I think it should
be. So when do you not update traverse?
Yeah, basically it should be that if the case that happens again, I also have that, the value is lower, then I'd want to keep on repeating, right? So the bug that seems to come out from this is that instead of having an if val less than k, I'd want to have a while, right, for both of these.
Wait,
pretty much.
No, I don't think, no, that wouldn't solve the issue. The thing is, if you think about it carefully, right, what your traverse pointer it's doing is that it points to elements that are equal to k, right? So
I mean, not necessarily. It points to elements that we've processed so far, right? In a sense.
Sure, but what I'm trying to say is that you have an invariant, a loop invariant. You've got your low, you've got your mid, and then you've got your high, right? But then this is the end result. When you're starting out, you'll have a bunch of elements here, right? Elements to be partitioned.
Yeah.
Right? So what your traverse is doing, your traverse is essentially this wall, right? That's moving until it reaches high. right?
Sure.
So what you traverse, so there are a couple of cases I think that you're missing. One is that you need to sort of increment your traverse when you've swapped with a lower element, right? Because you know that if an element is lower, if the current element is lower than k, right, then you've swapped it with the low, right, and then you have to move your wall up by 1.
Right. So the thing I was gonna get to is pretty much handling this. Like what I was gonna follow up with after updating the while is like the case that I'm trying to really avoid is say I have 3, 4, 5, 6, 6, right?
Mm-hmm.
When I initially do the swap for say my traverse is over here and my right section is here, right? I'm gonna end up or let's put another element in the middle, right? Yeah. So let's say I get to the 6. I end up swapping with the 0th element. So now that the 6 is, at the last element and I still have that 6 here, but now my right moves up here, right? I still want to process this array element and I don't want to move traverse forward until I'm done.
Right.
So that's the whole while with val is greater than k is supposed to equal, except I'd have to recalculate val every time, right? I'd have to set this again. Val is equal to r of traverse. So because I'm writing the code like this, I really just want to place this r of traverse everywhere, just to make things simple. I think that's what you're trying to get at, right? For part of it is that like I'm not going to be correctly processing items on the right. I think for the left, this case doesn't apply. When I'm trying to update on just items that came previously, because I'm always guaranteed that everything to the left is going to be lower, right? But I'm not necessarily guaranteed that everything that I swap with on the high end is not going to also be in high, right?
Right. Now, I think we're both trying to say the same thing. I would write the code differently, but sure, this would also work.
Right. Yeah. Is it okay if I try and run this through with a test case?
No, I don't think that would be necessary. I'm pretty sure this will work. So let's look at the runtime of this function and the space.
Yeah. So the runtime is still the same as before, in that it's linear according to the length of the input list array. And from earlier, we also mentioned that the space, all we're using is 2 separate pointers, so it's constant space complexity.
Okay. So yeah, so let's look at another problem. The idea here is that you're given a list of integers again, right? And the idea is that you're being asked to write a function to determine the maximum length subsequence of consecutive numbers that can be formed using elements from L. Right, so that's the idea.
Sure. Is there an example of one of these?
Sure. So say, for example, you're given a list, say something like this, right? And so you have 4 here and a 2 there. And then right after the 2, you've got a 99. Right after the 4, maybe you have a 100, right? And then you've got some random elements here, 9, 49, 51, and so on and so forth. So here, you basically have to choose from 2 subsequences, right? So one of them is, the list that can be formed by taking the elements 1 through 5.
Okay.
And the other one is the list that can be formed using the elements 99 and 100, right? Because they're consecutive. So that's something you have to keep in mind. And then you take the maximum length of the 2, and the answer is 5.
I see. Okay. So the way that we're treating this is not, when you said, subsequence of numbers, I thought they were continuous, but instead what we're having is we have the entire set of all of the numbers in the list, and we want to see which ones can follow in direct sequence.
Right. So the idea is that they don't have to be contiguous, the elements in your list, but they do have to be consecutive numbers.
Okay, so right off the bat, one of the things I imagine I would need for this is to put all of my items into a set, just so that I can do quick membership checkups. So, like following the logic given in the example, it seems like what I want is, say I'm processing these items in order, right? Then when I get to a 5, what I want to check is how long can the streak go, right? So I would check, say, 6, 7. As soon as I find that an element no longer exists in my set, then that means that that streak is done, and I can determine the length of, that streak, right? In the sense that when I get to 2, I would search for 3, 4, 5. I see my streak is length 4. And if I, looked for 3 and I found that it wasn't in the set, then that means that the longest streak from that point is, 1, right? Looking at the complexity of this, it ends up being that we get runtime complexity of n squared, big O of n squared, because it seems like the worst thing that, it seems like I would keep on going down every streak and every number, right? And the reason that it's n squared instead of just n is because I'm repeating visits to numbers. So say I have this 5 and I see, oh, 6 doesn't exist, then I end my streak. I get to the 2, I check 2, 3, 4, 5, cool. So I've gone through all those elements. When I get to the 3, I'm also going to recheck all those elements except for the 2. And when I get to the 1, I'm also going to recheck everything, right? I'm going to get the correct answer, but the runtime complexity is big O of n squared, and then big O of n space complexity. Is it okay if I code this, or would you want an improved solution?
No, I mean, I think you're ignoring a very important fact. Right? The fact that if a number is part of one sequence, say for example you've got, it cannot be part of another sequence. It can only be a part of one sequence, maximum, right? And let me give you a proof by contradiction. Say for example, there is such an element, right? Say for example 5. So 5 is a part of 2 sequences, say. So you've got like 3, 4, 5, and then you've got 5, 6, 7. If 5 were a part of both sequences, then both of those sequences would be the same sequence. 3, 4, 5, 6, 7.
Right. Yeah. So I
can you use that information? So basically, when you go through the streak that you mentioned, right, every element that you visit wouldn't need to be visited again. So can you prune your set somehow?
Yeah, I think so. So this does end up being a solution, but right, you're saying that we can improve it because the complexity is a bit too much because we're revisiting. The example that you used, you said that you had 2, 3, 4, 5, and then 5, 6, 7, or something like that. Seems like the important detail was that you were in the middle of a streak, right? So basically, you want to say that if I'm in the middle of a streak, don't start going down the streak, right? What information do we
have? First, that idea would work, right? But I think you're focusing on a subset of the information you have. It's not the middle of a streak. If an element is part of any streak, it doesn't have to be in the middle. It may be the beginning as well. If it's part of any streak, it cannot be a part of a different streak.
Well, I mean, it can in terms, because all we care about is the length, right? So if we have 4, 5, 6, and then we have 6, 7, 8, say these are 2 different streaks, you can merge them together, right? And because all we're looking for is the length, you would want to find the maximum, right? So what I was getting at is 6 is in the middle of a streak here, right? And we can figure that out because we know what all of the numbers are, right? Because we have a set of all of the numbers. So what I was doing earlier is I was saying I would search both from 4 and from 6, right? But that ends up being too many repeated searches. But it seems like it's still valid to do this operation, right? Like even though the runtime complexity is high, it's still correct, right? Because as soon as I start from 4, I'm going to merge them. Do I have that?
So what are you saying?
Yeah, so what it seems like for the whole repeats is that I just want to say that if I'm in the middle of a streak, then I shouldn't start it, right? So I need to, it seems like the thing I need to figure out is when am I in the middle of a streak? So how would we actually do that?
I think again, you're focusing on a subset of the information. You're not using all the information. It has nothing to do with the fact that it's in the middle of a streak, right? So I think if you, sure, I mean that would work, but that would be solving a difficult problem. Like there's no way to tell if something is in the middle or not. No easy way to do that, right? But what you mentioned before is very interesting though, right? You mentioned that you would make a set from your list, right?
Right.
So what property does a set have?
It gives you big O of 1 membership checkups.
That basically O of 1 lookup, and what it also does is that there are no repeating elements in your set.
Right.
Right. So can you use that information?
Yeah. So
that in combination with the fact that an element cannot belong to two different streaks. Once you've seen an element, you can prune your dictionary or your set, right, and get rid of that element because you know for a fact that it won't belong to a different one, and you won't start from it.
Right. Yeah. So it seems like if I use a set, then if I'm at 6, as I'm traversing through, I can just check for 5, right? And if I check for 5 inside of my set, then I know that I shouldn't be starting this streak. But if I'm at 4 and I check for 3, I see that that's not in my set. And from that, I know that I should start this streak, and then I would keep going down until I know where to find something, right?
So what we're going back and forth on is basically an implementation detail, right? What I'm saying is we are essentially looking for the same thing. We're using that property that an element cannot be part of two sequences or two streaks, as you call them.
Yeah.
Right?
Yeah.
Now, how you implement that, that's up to you. What I had in mind is that as you're going through the elements, you basically max out on both ends. You go right, as far to the right as you can, and as far to the left as you can, right? But I guess what you have in mind is to find the beginning of the streak first, which is valid as well.
Okay, yeah, because it seems like...
So I just want to make sure that you're aware that, there are two competing choices here, and your implementation will be different based on which one you pick.
Sure. It seems like for both of them, the complexity ends up being linear just because I'm not going to revisit anything, right?
Exactly. They're essentially the same, but I don't want there to be, the thing is, yeah, you have to make certain design decisions in terms of how you will implement them. So if you it's what I want to make sure is that you have a clear idea that there are two different ways that you can go.
Yeah, I see what you're getting at is that I would just pick any middle element and then I would remove from the set, right? As I traverse both left and right, and that gives me the length.
So I mean, it's what you're saying is basically find the beginning of the streak and then move in one direction, to the right, which is valid as well.
Cool. Is it okay if I code this out?
Yeah, absolutely.
Sure. So longest subsequence, continuous, and then it's an array, right? So items, the set made from the items in the array, and we have our initial longest is set to 0. I was going to say that I guess you still need to check that if array is none, then 0, just in case. If we have a non-length 1 array, then longest by default is 1, but it's fine. The rest of our code will catch that. So let's say we go through value in array. So there's the two different ideas, right, that we can take is we travel both directions or we travel in one. I'm pretty sure I could, they're short enough that I could probably show both of them. Let's say that
just pick one and go with it, right? But make sure that you don't mix and match.
Sure.
Which is why I want to make sure that you're clear that there are two different approaches.
Yeah, sure. So from my one, I guess that's the one I originally thought of. I could say that if value minus 1 not in items, then this isn't the beginning, right? Otherwise, we say our initial streak is equal to 1, and then we're going to have that while value plus streak in items, we're going to increase the streak by 1, and then we're going to say longest is the max between longest and the existing streak. So actually seeing the logic for that, we're saying, yeah, the current longest chain we have is 1. We keep looking for the next item in items until it turns out that that next item no longer exists, right? So if we find 4, because 3 doesn't exist, we'll go down this while loop. We'll say, oh, does 5 exist? It does. Okay, now our streak is, and so our longest is going to be 2 at this point, if short of 4. And now we're looking for 4 plus 2, which is 6. We find that still exists. So now we say that the longest is 3, and repeating on until we search for 9 and we find that it doesn't exist, because our streak will be value 5, which is the length, and we'll exit, and then we'll eventually get longest is 5.
Mm-hmm.
Yeah. So should I test this out with an actual test case?
Hold on. I don't think a test case would be necessary. I just want to make sure that I have the logic here. Longest. Okay. Yeah, I think this would work. Yeah.
Cool.
Value plus streak. Okay. Yeah. So this would work. All right. So let's look at the runtime of this function.
Yeah, so from before we mentioned that it would end up being linear just because we're only going through each of the items once, right?
Mm-hmm. Okay, and the space?
Is also linear because we have the set of all items.
Right, okay. So yeah, I think we're almost at the end of our session. What I want to do is I want to give you feedback. But before I do so, give you feedback. Do you have any questions for me at this point?
No, not yet.
Okay, cool. So I think overall, like problem solving wise, I think you did well.
Right.
So the second problem that we solved, it's actually a hard problem on LeetCode, right? So I think you did a good job there. With the first problem, I think you did a good job as well. There are a couple of issues I see, and that, like, the one issue I see, right, is that, sometimes I feel that, like, when you were solving the problem, I felt that there wasn't this elasticity of mind. Like, you weren't willing to consider other perspectives as well, right? Which is something, like, it didn't hurt you in this case, right? But that is something you definitely want to have, to be able to sort of look at the same problem from different perspectives. And I say that because if you're stuck, that's the one skill that will help you become unstuck, right? It's not about, what I'm trying to say is that like overall, I think you did really well. So if I were to make a recommendation, I would say that you'd be flown out for the on-site interview. So I would definitely say that, right? But I think, would you rank at the top of the candidate pool? Probably not, simply because you haven't demonstrated that elasticity of mind that I'm talking about, right? So the way it works is that each interviewer gets assigned a pool of candidates, right? And they have to rank the candidates, and they can only recommend that the top 2 or 3 candidates be flown out for the on-site interviews, right?
Right.
In that sense, I would like say that you would definitely make it to the top 2 or 3, right? But you probably wouldn't be the top candidate, right? So what are the privileges of being the top candidate? They basically interview with the team that they want, right? So say, for example, if somebody's resume is geared towards computer systems, they'll interview with the computer systems group, right?
Right.
If somebody's resume is geared more towards machine learning and stuff like that, they'll interview with the machine learning group and things like that. So there's some perks associated with, being the top candidate in the pool. So the feedback I'm giving you, it's nitpicking at this point because you did a great job overall. But I would say that you want to develop that elasticity of mind. What that really means is taking a step back, looking at the problem from many different angles, and basically, questioning your assumptions at every single point,
Right.
at every single step. But you don't want to take it too far. You don't want to sort of, question your approach all the time. What I'm saying is that you should always ask yourself, can I do better? Like, say, for example, the first question, right? You assume that it was a linked list. For that kind of assumption, you definitely want to run that by the interviewer. Like, is it a linked list? Is it an array, or things like that? Right.
Yeah. For the part of it, I felt like we were talking about the same things. Yeah, for like the traversal through the partition as well as the whole, middle section. To me, it seemed like we were pretty much talking about the same idea.
Yeah, I mean, the idea, like for the traversal, the idea was the same, right? But for the second one, the longest subsequence continuous, the idea was slightly different, right? But that's fine. It's okay to have a different idea as long as it works with the same complexity and all of that, right? But what I'm saying is that, um, like, you should basically question your assumptions more, right? Say, for example, with the first question, I think you started solving the problem without um, questioning the assumption that it was a linked list, right?
Gotcha.
So what that, like, for these small questions, you're getting by, right? And the interviewer sets you straight and things like that. But for on-site interviews, say, for example, if it's a really complex problem, right? A small assumption like that can really ruin your solution, right? Um, and, there's a metric associated with that. Like, does the candidate basically take a step back and evaluate different options before diving in? Because real-world problems cannot be solved in 5 or 10 minutes, right?
Right.
Often there's a design phase associated with that. You basically assess many different options and you pick one option based on certain advantages and disadvantages, right? Certain trade-offs. So they want to see a demonstration of that, right? So I think you did a good job of that with the runtime and the space, but I definitely think that there's room for improvement when it comes to looking at different ways of doing things.
Right. Cool.
Yeah, so that's the feedback I have. Any questions?
Yeah, I guess the only thing is I'm kind of surprised that this one's a LeetCode Hard because like usually those are like complicated DP problems, right?
Not always. I mean, there are many different topics, right? But it's hard not because I think, it's hard because of a couple of things. One is that you have to choose your data structure carefully, right? The second thing is that, um, yeah, I mean, it's not really, most of the problems on LeetCode aren't that hard. Like the hard problems aren't that hard. They basically have more tricks associated with them, right? You're comfortable with lists, which is why you sort of figured out the tricks on this one. But what I'm trying to say is that you have to basically make sure that you know the techniques. If you know the techniques, the questions really aren't that hard.
Right.
Like the O of one lookup and things like that, right? So once you realize that you need O of one lookup, a dictionary is the first thing that makes sense, or a set rather, right? Things like that. So what I would say is that the feeling I'm getting is that you're very comfortable with arrays and things like that. We haven't had time to cover, other topics, so I can't speak to them. But from what I've seen, I think you're very comfortable with arrays, and yeah, I mean, good job overall.
Cool. Sounds good.
All right. Well, if you don't have any other questions, I guess that's everything at my end.
Sure. I guess thank you for your time and especially
Of
the
course, my
feedback.
pleasure. I wish you all the best.
Thank you and
Take
have a
care,
good
man.
day.
Bye.